Question 7 says we need a tangent to the curve when it is vertical. So vertical tangent means we need to be able to divide by 0. So the first thing we're going to do is differentiate this. And since it's an implicit function, we're going to differentiate this implicitly. So as I differentiate the y squared, I'm going to, every time I differentiate the outside y, I'm going to then add as a chain rule the derivative of y, or y prime. For the xy, it is a product, so I'm going to differentiate using the product rule. So we're going to end up with 1 times y plus x times the derivative of y is going to end up being y prime. And then differentiating the rest plus the derivative of the constant to 0 equal to 0. So once we've done that, we're going to group our y prime so that we can solve for that. So we end up with 2y times y prime minus xy prime. And then we're going to move all the other terms to the other side. So we have a negative y. It becomes positive y on the right-hand side. Having two y's and having two y primes, to solve for that, we factor the y prime. And then isolate the y prime by dividing. So we end up with the derivative is equal to y divided by 2y minus x. Okay, so now we've generated the derivative. We need a vertical tangent. Okay, that means that this denominator must be equal to 0. So when I write this out, my equation I'm going to solve for is 2y minus x equals 0. Now, the problem with solving for this is that we have two variables. So to solve for two variables, we need a system of equations. So we have one equation. We need a second equation with x and y. And that second equation is going to be the equation that we started with, y squared minus xy plus 9 equals 0. So I'm going to use that as my second equation. Y squared minus xy plus 9 equals 0. And now I have a system of equations where I can solve for both x and y. So it looks like it'll be easier to substitute for x and isolate the x and substitute that. So I'm going to convert this into 2y equals x. And then I'm going to replace the x in equation 2 with the 2y expression. So I end up with, in my equation 2, y squared minus, I'm going to replace that x with a 2y times y plus 9 equals 0. Now I can solve this equation. I end up with y squared minus 2y squared, so that's going to be negative y squared plus 9 equals 0. Y squared equals 9, so we get our y value being equal to plus minus 3. Okay, if we take a look at our answers, okay, the tangent to the curve is vertical when y is equal to plus minus 3. That's going to be D. So the answer is